Acting as the ABS chair has given me lots of opportunities that I normally would have had difficulty having. I've been able to support students, get instrumentation for the student experiments, not only in the classes that I teach, but also in the research. And this is an example of the commitment that ABS has had with Michigan over the years. Currently, ABS supplies internships, which are extremely valuable to our students. They also provide fellowships, which our students rely on to complete their education. So the practical experience and the financial help that we get through ABS has been instrumental in us graduating at what I feel are some of the best naval architects in the country. As educators at the University of Michigan and other universities, our peer institutions, we see that the skill set that the students need is that not only do they have to understand how to do computer programming, but they also have to understand the underlying physics for the systems that they're looking at. So this is always a challenge. How do you let students who are very good at computer coding give them the basics in mechanics and applied mechanics, fundamental naval architecture? It's very interesting, but also very challenging, but very rewarding to see the students who are able to take a system, draw a free body diagram, code it up, and then perhaps write a computer program that operates the system. So one of the challenges as educators that we face, and we rely on our alumni, the industry, and particularly companies such as ABS to guide Michigan in, is how do we balance with our educational program, the students, the need to capture fundamental, what people might call old material or well-known material, along with the newer developing computer science and artificial intelligence fields. So naval architecture and marine engineering, as I had mentioned, is really the design of systems or systems integration. And this fits in with the research effort the department has, but also fits within the broader department or college-driven initiative. Part of that will be MC, which has to do with marine activities, where naval architecture and marine engineering now is adapting robotics and the study of robotics and the design and operation of robotics and artificial intelligence into the marine community. The potential for robotics and the potential for artificial intelligence is that you can make ships more efficient and safer. The challenge, of course, is that the black boxes which drive the robots are written by human beings. And so we need to teach, educate future engineers on how to do that, and so they can do that safely, and so there are really no mistakes or bugs, if you will. I'm looking at primarily the way that you take these high-fidelity programs, the CFD computer-aided designs, the computational fluid dynamics, FEA, FEM, and how you incorporate that into the design process. We look to ABS, particularly the ABS rules and the guides, to give information and guidance to the students because they're not seasoned naval architects. And the ABS rules give constraints or guidelines by which the students then can look at their designs and their application of the designs and the fundamental principles that they're learning within their education experience itself to come up with future and leading edge ships and offshore platforms.